Okay, fine. Right, some of you have met Dan Ridley Ellis before, one of my colleagues. You met him in CTR07104 communication. You'll have met him. So, they're his slides, they're not mine. I work beside him, and in fact, he's my line manager. So, I'm quite happy. That didn't work. Why did that not work? What it is with this pointer is hit and miss, isn't it? Right, so I'm not going to try and pretend they're my slides. I've left his email address on a lot of them, mainly because his slides are really high quality and he's actually done a lot of work in the background to make these slides happen that I'm not going to try and take credit. So why timber? Well, what timber is, first of all, well, this is a Yoker project building. Mila Duncheby, you've never met her. She used to work here. Well, her PhD was on this building here. It's a Yoker in Glasgow, Scotland's biggest CLT building. This is a Makar. Come over here. This one here is actually a Makar building. You will see more of this later on in other modules that I will present in. And it's quite innovative in its own way. This one here, a guy called Professor Robert Hairstands, his research work went into that, and his book that you've all used last year with me talks about that. This site, this is actually all Commonwealth Games, and these were all built very, very fast, off-site manufacture, then modified because it was a athlete's village. Sorry, man, your way. I need to be near the microphone, don't I? So, but for us to design buildings like that with timber, we need to know a little bit more about timber. This is an extract of BSEN 338. I think you started trying to use, compare the samples that you've got. So right now you can't use that just yet. But for the next again coursework, you could. But then, because all 3 samples, all 9 samples actually, are all from the same species and the same batten of wood, you then hypothetically could then say the original board of wood would be grade something, right? But you've not been taught that yet. You'll get some of that today, but you'll get more of that next time. This shows you different grades of wood. The most common grades is C16 and C24 for construction timber, but there's actually many more, but that's just some examples. Some of the topics we're going to cover. And what is wood and what are trees? Good questions. Issues. Water. Figure is this distortion. You've all seen bits of wood that have been lying out, got wet, and they've dried, and they're just warped and twisted. So figure, we call that, and defects can be knots or cupping of the board. These words here may come up. So in this lecture here, you'll find your first question in your class test will primarily come from last week and this week's lecture. And it's a question you cannot skip as a compulsory question. So I'll just sit back and listen today, and then either watch the recording or just look through the notes yourself, as in these notes, the slides, because this will take part of your class test. So you'll be asked what these words mean. 2 types of wood, softwood and hardwood. I've only got hardwood samples here, but we'll be playing with those later on potentially. They are somewhat different. There's a basic understanding of botanist view on trees, softwoods and hardwoods. However, hardwoods and softwoods are distinguished not by how heavy the wood is, right, or how strong it is that as a hardwood or a softwood, it's by how it reproduces. If it's a naked seed or a closed seed. We do have some slides on this. I'm going to go over it fairly quickly because there's a lot of slides here. We'll try and go through it at least 70 slides, not the full 124. But the rest of the slides are for you to read afterwards. We can see here a softwood. You get asked what a softwood tree is. I want to use this word here. And hardwood. This means enclosed seed, like an apple, or a cherry, or a cone. Well, the cone is on the tree, it opens up whilst it's on the tree and the seeds fall out of it and the seeds fall naked to the ground. It's literally the definition of hardwood and softwood. So you've got things like balsa wood. Normally I'd bring out big samples of wood and you'd have to play a game of identify the softwood and hardwood, and I'd put a piece of balsa wood in there and people would go, that's definitely softwood. That's a hardwood. So it really is about how the tree reproduces. And then within the hardwood and softwoods, there's lots of variants. Lots of variants in what we can do with that tree. So we've got, for example, where the source where the trees come from, the kind of properties, the applications, the way it's been processed in the sawmill. We've got the diversity, the variability of the tree. Hardwoods tend to grow more randomly, is one way of doing it. Softwoods tend to grow more as a straight pole. That's not always the case. More of that later on. We'll just fire through these. Right, a tree in general though does not grow up, right? Bamboos, I believe, grow up, but trees don't. What trees do is they grow outwards. Okay? The best example of that would be this ash. You can see all the lines, can't you? Pass it around if you want. You can see all the lines. Trees don't grow vertically, they grow outwards. But because it's a cone shape, as it grows outwards, it ends up getting taller. And that's the same with your branches as well. It's exactly how trees grow. You might be asked to show something like this. And this is a log cut through a tree. We've got the growth ring, so it's going to grow wider as it goes. We've got the pit, the heartwood, the sapwood, the cambium, and the bark. You'll see more about that later on, but you'll want to be able to draw that and identify that and also explain what these mean. On these slides, we might not have time today, but you could get your phone out and scan all of these codes. I suggest you'll want to do that later on when you're revising for your class test, because the questions that will be asked of you, that will be answered in a lot of these, and it will give much further detail. Actually, just whilst I'm there, what one is it? There are some that are just awesome. This is one of them. So, Professor Dan Ridley Ellis, he's a bit of a maniac, right? He loves his technology. You can see what he's done, and there's a learning material in. Oh, you've done it, yeah. So it's do scan these images here. There's a lot of further content within there. You can see a Douglas fir. Looks quite differently from the sycamore. They're roughly the same, but because one's a softwood, one's a hardwood, there is a difference in the cell structure We'll come to that later on. Right, we talked about that section before through a tree. We've got the heartwood. That heartwood's already, it's not dead, but it is. It's essentially dead, right? It's older wood now. It gets stronger. That's where the strong part of the wood is. The sapwood is still a living component. We can see that the sap is being, you know what a capillary action means? What capillary means, guys? It means that it's drawing liquid up. Well, the capillary action here, the sap goes up within the sapwood, and the extract from that is going to come down in that bark process. Literally, the sap goes up and comes back down here within that bark. There's the cambium in between the two. That makes sense. So the tree. So have you ever anyone cut a tree down before or cut a limb off a tree? Yeah, you have, right. So I was out with a chainsaw a wee while back and I was cutting limbs off a tree. I was asked to do it by the farmer, and literally I took a video and it was as if the trees were crying. I took all these big limbs off because they were leaning over into the trail for the horse riders, and it was literally as if the trees were crying because it was the wrong time of year to do it. I was asked to do it. That sap movement, it literally is like a tap. It literally is a lot of liquid coming. So just while we're on that note, if you've got an apple tree or a fruit tree that you don't want to kill, but you don't want to damage the fruit, the crop for that year, the best time to do any heavy pruning would be January, when it's the height of winter, when there's little to no sap moving, right? But if you try and do it any other time of the year, like even now, it's too late. You'll put the tree into shock, and you'll probably lose about 1 or 2 years worth of fruit. So anyway, that's way off topic. Right, tree rings, so the annual growth of the rings. So another example, probably the best one actually. These different rings that you saw. Again, this is ash. It's a hardwood, and it's a very slow growing hardwood. But if you put it under a microscope, it looks something like that. This is who done this? That would be one of Stefan's photos or images. He done some for me more recently. It was really quite nice. We've got the early growth and the late growth. Early growth is where it's growing faster. There's more sap moving. It's warmer, and the late wood is the end of the growing season or over winter time, and it is visible. As I say, it is visible under a microscope. See why it's visible. This is a hardwood, and that's a softwood. They look quite different. You see that? Hardwoods are different, so it's not just because of how the trees reproduce, but that is the defining factor. But you'll find hardwoods they do look different under a microscope to softwoods. The general theory is pretty much the same though. With that moisture, sap movement, vertically and horizontally. We also need to move moisture, the sap horizontally as well, and they've got a different name. So that's an image of this there. Quite interesting. Oh, excuse me. Hardwood, softwood as well. Right. So again, my colleague Dan loves these 3D printing, so he's printed off these sorts of things. But there's these models of how that cell would look for a softwood and for a hardwood. It is quite smart. There is a 3D scan. You can QR code it. Yeah, you can scan those later on. Again, it's actually very worthwhile. I'm quite impressed with that. You should definitely scan it later on to see, because literally when I describe my trees is a bunch of straws. Your straws. That's literally how it works. There's a video somewhere of a young girl. I've tried it, but I've never managed to reproduce it yet. Of getting a dry piece of wood, putting it in soapy bubbles at the bottom, and then blowing air through it. Actually produces. Not managed to I've not tried very hard to reproduce that, but I need to try and reproduce that at some point. Again, here's a video. It's actually an American university. It's got some lovely content as well that they're using, so we're just giving you access to that as well. Again, this is only a second year class, it's not a third year class. This is not a fifth year class. So, some of this. But there's also a video here, a different video, on identifying hardwoods and softwoods. So, I've got ash. Ash is currently my favourite wood at the moment. It just looks beautiful, in my opinion. This is beech. I had a lot of beech before. I had 1.5 tons of beech. And I made 2 tables, I made a kitchen unit, as in for my camper van. I made quite a lot of it out of it, but I now have very little of it left. So I want to get some more of this stuff though. Now this is cherry. That's just oak, but I'm going to use them in a minute. That's not very special. But oak is quite nice, but this is greenheart. I think you've seen samples of greenheart before, or my first years did anyway. Sample of greenheart. When you cut it fresh, it looks a bit green on the end grain, and it's heavier than water. I don't really tell by this small sample, but that's denser than what water is. So you can see different hardwoods look quite different. I do have some samples. Kenny's got them at the moment of about 12 different species of tree, and it's all etched on them what they all are, and they're identifiably different. But anyway, that's not overly important just now. Right, we'll look at wood. This would be that way there for me. We've got tangential, so there's the ray. Rays will go that way, so the light wood direction horizontal. They're going that way as well. We'll look at the longitudinal, tangential, and we've got the rays might be the cracking and things like that. You'll see rays. I do have a sample somewhere that shows that. I'll show it to people in the lab. Okay, we've got, let's talk about knots. We've already talked about knots, haven't we? We talked about live knots and dead knots, or was that a different class? Okay, very similar, that was a different class then. Knots, there's two different types of knots. There are live knots and dead knots. Essentially that is a branch. And whilst that tree was growing, that branch was still alive. It's a dead knot. When that tree was growing at that part there, that branch was already dead and it hadn't been taken off the tree. In some countries what they'll do is they'll take off the old branches as the canopy gets taller, depending upon the species of tree. Because some species of tree, the branches will fall off naturally. If you allow them to fall off naturally, or you take them off prior to that, and as the tree grows, you'll get less of this sort of knot happening. Or if it's a species of tree like what we grow, Sitka got lots and lots and lots of branches, and the branches don't fall off. When they die, as the canopy cover gets taller and there's no more light getting to those lower branches, they'll just die and they'll stay on the tree. And as the tree grows out, you'll get things like this, dead knots. So there, I would say that is a massive weak point on a defect in the timber. This can be a defect, but in actual fact, it's quite often not a defect in the timber. There's rays there, actually, that's rays. Right. Again, maybe not just now, we're running out of time. Go back to the slides later on and scan these. What is really quite interesting, what Dan was trying to talk about here, is as a branch or a tree grows, if you scan it later on, it is quite smart, especially this one. As the tree grows, His famous comment, or it's quite famous, is a tree's only good for one thing, it's being a tree. And as a tree grows, things happen to it, wind damage or whatever, and a tree might start to twist and warp as it goes, and that's in reaction to what's happened to it, if that makes sense. So if you've got a tree that started to grow and twist and move up because of environmental conditions, that means you've got inner stresses in that wood. As you cut that wood through, as there's a cutting pattern there, you can see how the radial pattern's quite different in each of them. Does that make sense? And so how you cut that wood up, would have a massive effect on the end product. That makes sense. So for example, quarter sawn wood. Example of quarter sawn here, there might be. Really, quarter sawn wood, I'll show you later on. Quarter sawn wood is the perfect material for making furniture out of, because it's going to have very little movement of moisture, of dimensional stability, the way how it's been cut. It's unlikely to warp and twist. So when you scan a piece of wood or a big log of wood and you decide how you're going to process it through a sawmill, it can be quite important. But all I'm saying is, do scan these later on and you'll get to see. What you'll see here though is the knots in the branch, in the log of wood. The X-ray machine will show you where the knots physically are and where the defects might be. So again, the direction of the grain can change depending upon where the knots are. Now, if it's a live knot, that doesn't necessarily mean that it's weaker or stronger than the areas without the knots. If it's a dead knot, then it definitely is. The whole lecture just on this very thing. I think you've got the gist of it. Right, so directions simplified for engineering: parallel to grain and perpendicular to grain. That's a good example. That's a wedge. I want to make a wedge for a door. Now, I made some wedges before for someone and I was having a bit of a laugh, right? This is a longitudinal grain. You can see it's longitudinal. So that's actually a perfect shape for a wedge put under a door. But if I cut a wedge the other way and the grains were going this way here, it'd be very weak. You could just break it like that. So I intentionally cut some up that way. Yeah, I did do it. I did do it intentionally. And they're absolutely useless because they were quite weak that way. So for engineering, we don't want to get too particular, but it's only people like Dan Ellis and Wojciech, who most of you have met, who get very caught up in the much more finite detail. But for engineers, we just need to know parallel to grain, perpendicular to grain, and the load properties are incredibly different. As you already have the answers, so you've already done your coursework. About to resubmit it though. You should know the difference in parallel to grain and perpendicular to grain, and you'll probably have an understanding of what ratio it is per millimetre square. If you don't, you'll go back and you'll add that in, won't you? Right? Because normally that is way stronger than that per surface area. Right? But also in that end grain cut, we've got parallel to grain cutting, high strength and stiffness, very little moisture movement. Perpendicular to grain cut, low strength, i.e. it would just break. Essentially in tension, it would just pull or snap. And moisture movement is quite easy. Right. So within the actual wood itself, we've got cellulose, lignin, hemocellulose, we've got extractives, and we've got obviously a big bunch of water in there. Again, you saw some of this last week. This is more how a tree grows, and this is what you end up with. I'm not going into too much detail on that. You had that last week. That's it there actually. These are not our images. These came from somewhere, or are they ours? I don't think they're ours. Dan's taking them from somewhere, and it's a nice understanding of this is softwood. That's a softwood, and you can see literally within that what's happening. You won't be asked to memorise that, but it'd be good for you to understand a little bit more in what's happening within the cells of a tree. This is where you want to start taking notes. You already know how to calculate moisture content. Remember, you need to reference. You need to reference where this calculation comes from. It tells you in BSEN 408 what document you find to calculate that. So you should reference that document. Don't just take it from my slides. Okay? How do we get the mass of the oven? Okay, so you chuck it in the oven, 103 degrees Celsius. What was our oven set at? Was it 105? Who cares? 24 hours, job done. Well, for samples this sort of size, 24 hours is absolutely fine. Bigger samples that you've got have to go on for longer. In actual fact, I chucked in some dowels last week into our oven down at Seven Hills, and it had been in there for a full week. It makes no difference to them. They're not going to go on fire. So the moisture content, this is Sitka. Yeah, it is Sitka, yeah. Now, just an example of how much water would be in that piece of wood equivalent if it's at 70% moisture content. If it's 265% moisture content, that means the weight of the dry wood with no water in there at all, the water that is in there is the equivalent of 265% the weight of the dry mass. So that's all that it means. So that means that all that water there is essentially equivalent of water that's physically in that bit of wood. It's very, very wet. And you can see that it's wet. The ink used to draw on the actual sample is smudging and smearing because it's absolutely like a sponge. Now, when you cut a tree down, again, someone who has limbed a tree before, and you touch the wood, it's absolutely soaking wet, isn't it?
I was going to ask, because palm trees and things like that.
Sorry? When it comes
to palm trees and things like that,
yeah.
or meadows, because they're a fibrous type, right? Like, their moisture obviously is held at seasons entirely. I mean, sometimes it'd be really wet, other times it's bone dry, and it just burns out saws and things like that.
That's why I was talking before about cutting an apple tree or a cherry tree. Do it in January. In the UK, do it in January, right? Yeah. In America, no idea what time of year to cut a tree down. But you want to cut fruit trees down, or not cut them down, don't do that. You want to prune them heavily at the time of year when there's a least sap moving. Yeah, but when it's the wrong time of year for cutting a tree, and I've done this, I've had to clear a path for horse riders, and it's absolutely sodding wet. Or when you cut a tree down and you put it through a sawmill, and you touch the planks of wood after it's been came out, it's absolutely sodding wet. It's equivalent to that sort of thing, way above 100%. More water in there than there is wood, as in by mass, significantly. Bizarre. You then have to dry it down to about 20% moisture content commercially before you're allowed to sell it. Well, before you sell it, sorry. Right, anyway, so this is an example. An equilibrium of moisture content is circa 12%. We report our densities at 12%. There's some hints coming here. Right. Equilibrium of moisture content. So what we tend to do is we put our samples of wood into a kiln. Perfect. Yeah, we put our samples of wood into a kiln, not a kiln, sorry, into a conditioning chamber for a period of time. This is a much longer period of time, could be several weeks. And we'll have it at a temperature, say 25 degrees and 65% moisture content. 25 degrees and 60 something relative humidity, and we should then get our samples of wood at roughly 12%. We want them nearest 12% as possible is what we want, but what we actually want is the aim to come to an equilibrium, i.e. to stop moving. So what Wojtek or Dan or Dan's team will do, the samples will go in the kiln, in the conditioning chamber. They'll be in there for a period of time, weeks or months, and then we'll measure the moisture content by something like this. Use yours. First. So you can see that there. Was it at 11? It's fluctuating between 11 and 12. It's fluctuating, yeah. So we can see what moisture content that is. Now this has been in my office for a long time, yeah. This is actually oak. English oak, or some sort of English oak. That's a quick and easy way to get the moisture content. It's not as accurate as what you've done with the oven. That's a precise way of doing it. But we'll chuck it in a conditioning chamber and we'll keep measuring it every so often. When it stops changing and it's consistent, then it's ready to test. It would be roughly 12%. Then what we'll do is we'll do the testing, we'll measure the proper moisture content by doing what yous have done, make clear samples, weigh them, dimension them, put them in the oven, bring them out, weigh them again. We'd also take the sizes of them again as well, because we're not just measuring the moisture content, we're also measuring dimensional stability of the species of wood. So we'd do that. We would normally do that as well. Right, methods of estimation. Truthful in the ranges of between 7 and 3%. Doesn't measure near the end grain. Right, okay. So imagine that's my bit of wood. What I would do is make a clear sample. I would not take the end grain. I would take a bit from the end grain, because there the moisture content near the end of my sample will be lower than what's in the middle if it's a big sample. Yep. So I would take samples randomly in the wood, but not at the ends. There's different calculations. There we are. There's electrical resistance, which is this thing here, and there are much bigger versions of that, and I also have to go into a depth of the sample of wood. Yep. Fair enough. There's an accuracy to these as well. Right, so MC calculations. Mass before oven drying, bang. Dimensions before oven drying, mass after oven drying, there. What is the moisture content? What was the density? So there's the answers, nice and easy. And then another one, similar thing. So you've got examples of how to do it. Now, if the mass at 18% moisture content is 7 kilograms, what is the mass at 12% moisture content? This is what you'll have to do. You don't have to do it. This is only worth. So if you're aiming for 100%, right, you don't have enough time and you're running out of time and there's too many other pressures, forget this. This is only going to be worth a small amount. But if you're aiming for that 100% and you really want to get that top mark in the class, I hope you do, then this is what you would want to do. What would the mass be at 12%? Right, there's a worked example there. I'm not going to go through it just now. I'll let you do this later on. You have the slides, they're on Moodle. Adjusting for the MC. Right. Okay, now we're getting to something interesting. Again, these slides were meant for fifth year's master's level. They weren't really meant for second year, so I'm skipping over a lot of stuff here. We will, however, look at this document perhaps next week, only for 10 minutes. So you can do the thing you want to do, and the thing that I dearly want to do as well. But for just now, it's okay. Any questions so far? Talked about a saturation point, fibre saturation point. We're going to come to that in a wee while. Right, these are some slides that Dan done. I quite liked what he done. Took scans with his mobile phone, believe it or not, of different pieces of wood. He actually gave them names as well, and he then took the actual pieces of wood out to students and asked them to visually sort them and identify which piece of timber would be stronger than other bits of timber. And we had all different species of wood and all different cuts of wood. You know, I was saying before about how you cut a piece of wood out of a log. Where you cut it from is either better or weaker, depending upon where it's cut. They had all different types of characteristics. And then they put now this is actually one of our colleagues from before they moved. Yeah, it's the same rig we still use. Actually using that, literally that part there the other day there. Right. Probably quite good if you do scan this, maybe after today. What you're going to see today is that, but on a much smaller scale, like something that size. But what you'll see in that video is the real thing. Or is it that you see? I think you just see that actually. I do have a video of like what he's done. Afterwards, I'm pretty sure it's not a video yet. What you get is a 3D model of this. He's looking at a thing called local and global bending. You're not looking at that. All you're looking at is a simple test. So what you've already had in your lectures is different to what he's looking at here. But the bigger samples, like big sections like this is how we would actually do it. We're not going to go into his competition that he ran, we don't have time to do it, but he literally asked people to grade these bits of wood visually, and then he tested them, and then you got to see roughly where you were. These look if they're all the same species. Right. I'll do that now. But you essentially then got a whole graph. Some are quite good. Some are quite terrible. This is relevant for you. So 4-point bending, you're going to get something like this, like today, out of today's lab. Your lab will look something like this. It'll go up and up and up, then it'll fall off a cliff because it'll physically break. And that's what it'll get. And you'll get the F max, which is obviously that point there. It's just equals max range. You get the F max, 10%, 40%. You have to check that that's good enough quality of fit, the exact same as you did on coursework number 1, right? And if it's not, then you have to change it to suit. Coursework 2, you're not allowed to change it, of course. You have to just guess another point. Working, there we are. I'm going to say to you to ignore this slide just now. You stick to exactly what I've given you in my previous slides for coursework number 3. But when we're doing it commercially, we do local and global modulus of elasticity. You're just doing the one which I've already given you. Okay?
I had a question about how we work out the variance in our results. We using using it as a population or as a sample?
Population is 3. Your variance is just n equals 3. Yeah.
Why do we not use the sample formula? Like there's a sample formula and a population formula.
There's 2 on Excel.
There's just 2. I was just wondering what the difference
There's
is.
only 2 in Excel.
Well, there was probably more, but there was.
I don't understand, sorry.
For the doing the standard deviation, it gives you standard deviation E and standard deviation.
Oh, sorry!
Right.
Right, sorry,
two different ones,
right.
You don't know which one's right.
P. Just use P.
How do we decide which one we would use?
I'll tell you what, don't use Excel, use my method that I've shown you on the slides.
Yeah.
Right. And then use Excel and figure out why it's P. Right. The correct way to do it is how I've shown you how to do it. Right. Have you done it yet?
No, I've done it. I'm just wondering why
It's P.
Yeah, why P and why not S?
Right now I can't answer that question. I'll have to have a look at it and tell you myself. I can look at it after the lecture, or maybe later on. Depends what these 3 want to do. I think you 3 want to come to a computer lab. Feedback's awesome here. Do you want to do the Excel stuff today? Thank you, right. Good, right. So, we'll see. Right. But for this though, just do what I've given you. Don't do the 2 options here. But this is what Wojtek and I would do commercially, with much bigger samples, and we can only do the global and the local if we've got further equipment. Your sample's only that size. We cannot put LDTs on a sample that size. You can only do the global. Right, let's move on. Grading. What time is it? Because I'm just conscious of time now.
Right till 11.
Yeah, let's be quick. Right, grading. We've got appearance, usability, properties and values. We've got direct assessment. We can see, measure the exact things that matter. We should be able to grade perfectly. Sure. Indirect assessment. We can't see, measure exact things that matter. We cannot hope to grade perfectly. Okay, this is making more sense now. So, if we get all the data, we can do it perfectly. If we don't get all the data, we can't do it properly. So, what are we grading for? The whole piece, or what we could cut out of a piece. When we grade a piece of wood, we're actually grading that whole member of wood. That's what we're actually doing. If you then cut a piece out of that, you cut it in half, you've now got 2 pieces of wood that are no longer graded. You have to grade them again if you want graded wood. So when we buy timber from the sawmill, we would normally buy it graded, and it should be stamped on the timber what the grade is. I think I've already shown you that. I have. And it's already stamped on the wood. If it's not been stamped on the wood, we have to do calculations for the structural stability, strength of that, a slightly different way. So when we buy timber, we want it stamped on, or at least pay for it to have been graded. We cut it in half, or cut that board into 3 bits, bit with the knots drops away, and that would have to be graded separately from that, and there could be quite different grades, to be honest. Appearance of grading is most appearance grading is something slightly different. We do that for CLT. We want visual grade, meaning it looks good because it's going to be seen inside the building. But strength grading is where we're at. We cannot directly measure the strength, and we still have the piece of wood to sell, so we cannot break it and then go, right, so that wood that you wanted C16, right? Yeah, it is C16, but there's all the wood and it's all broken. It's no use to you. You want the wood unbroken. So the only way you can really do that is to have a look at the correlation between certain things, because if we test it properly, the only way to do it properly is to break it. So we have to look at the correlation to other things that are not going to damage the wood, so that we can grade it and then still sell the wood to you in a manner that you could then design with. That slide now, but look at this slide here. We grade a population, so a standard deviation of P, right? And we grade a whole population of, say, 100 bits of wood. We test them all, and we then get L curve for that population. Some of the bits of wood will not be possible to grade and will have to be rejected because of the wane or the cuppings too much, the disfigurements too much, and it's not possible to physically grade them, so they'll be rejected. They'll be rejected by hand. But the rest of the wood, you will have a standard deviation curve, something like that, a bell curve. There will be the mean, which is the average. There will be the lower 5th percentile and the upper 5th percentile, some of which will be lower than that lower 5th percentile. Does that mean if I sell you 100 bits of wood and you make 4 joists out of all of them, and 5% of them are going to be lower than that grade there, if I sold you 5 bits of bad wood, what have I done? What do you think? 100 bits of wood, 5 of them are weaker than what I've told you the grade is. There's my grade there. Not that, that's not my grade. My grade will be there. 5 of them are lower than. Did anyone watch that video that I asked you to watch of Marilena, the PhD student, talking about plums? Did you watch it? Anybody watch it then? One person, yeah.
Was it last week? Oh, I wasn't here. Sorry.
No. It's on Moodle, and I said, look at the stuff on Moodle and watch the video on Moodle. So in case I didn't show it in class, it was after class. So yeah, please go back and watch that. So no, the answer would be no, I've not sold you 5 dodgy bits of wood. I sold you a sample of wood, or a bunch of wood. Its characteristic values are that. Some of which will be 10% of which will be lower than. Make sense? You're going, it really makes sense. Some bits are really bad, some really should have been thrown out. No, that's not how it works. This is why grading is quite a complex thing. If you grade wood, you're going to. Now, here's the thing: when you design something, you never design anything with one connection, and you never design a floor cassette with only one joist. Never do that. When you design a beam or a lintel, that's something slightly different. You're specifying a much higher grade to start with, C24, or you're specifying an engineered wood product, which has got a much better chance of it never failing. Using a floor cassette, yeah, 5% of the samples will be lower than, but the work is a system. Okay, maybe that's confusing you. When we're doing something like this actually work from Robert Hairstand's a number of years back. I can see why Robert stole the photo. We had a big beam, or not we, before I joined. There are big beams in there supporting it. Now, this is now common practice. In actual fact, it's now even more common to have some of the materials, like the sarking, already on the roof as well. You build up the foundation of the house next door, and you lift, as in just the foundation, and you lift it into place. You're doing less working at height, but to do that, you need anchor points and beams in there that are sacrificial beams. So having more reliability, understanding of what you're building with is important. The properties are influenced by species of wood, the growth area, the forest type, the management of the forest, tree selection and breeding, processing and handling after processing. All of these things have a massive influence in the final product that you buy as an engineer and you build with. So when we talked about as an engineer, it's much easier to be a structural engineer designing out concrete and steel. A specialist in timber engineering, one, you get paid more, a lot more, and it's specialist area, and you'll never be out of work. You'll never be out of work anyway as an engineer. At the moment there's lots of jobs going. But I would say that designing with timber is more complex, a little bit more involved, but it's relatively straightforward if you keep an eye on what's happening. Right, so this is where Dan would have talked about the results of his little game, where you had 10 bits of wood and you had to grade them, the best ones to the lowest ones. And you would see some of the things you say, oh, that's really terrible, that's bad. Oh, that's just as bad as that one, blah, blah, blah. And you would think that you have to grade them a certain way. Well, in actual fact, it's really difficult to tell. So I've played this game several times with different sample sets, and I think I would be pretty good. You think Wojtek would be better than me, but it's really quite difficult to try and look at a piece of wood and identify what's going to be better than the other one if it's all the same species, just by looking at the figure of the wood. It's quite difficult. We do better than most people, I may add, because we should, but we don't get it 100%. That's helpful for my next few comments. Yeah, by the way, if not, dead nuts. That gives it away. Right. So, you know, before we talked about grading, and we talked about if we want to buy wood, grade it and sell it to somebody else without having to break it or damage it. There's things that help us do that. The density and bending stiffness. Density by itself is not the way to grade wood. It would not work. You can see the density here has a correlation between bending strength. There's a correlation there. The R squared value is 0.2. Actually quite good. It's quite good at R squared value. Remember, it's live data here, so that's actually not too bad. But it's not good enough. Basis of strength grading: grade some timber, determine the actual properties of the graded timber, convert this into a design value, assume that the grading will align with the produce the same results as long as the resource does not change and the grading rules do not change. Yeah, so if I give a batch of wood, I give it to you to grade the whole batch of wood, and then give it to you to then grade the same batch of wood, you should get the same results. That's what it's basically saying there. So it's not, the only thing it's varying is the individual bits of wood within that batch. So there's different standards used. This is an MTG. We've actually got two of those. Robert bought one and I bought one. £1,000 each, expensive. That's an acoustic grader using a sound signal. It hits on a small hammer at one end, and it travels down, and it then travels back up. The length of time it takes to travel that distance, combined with the weight of the wood, the mass, there's a set of scales that come with that system. You can then determine the MOE, the modulus of elasticity of that wood. So it's quite a nice bit of kit. Visual grading, right, this is where you want to take some notes. If you've been half asleep, wake up now. So, methods of grading structural timber. There's two main methods: visual and machine grading. Okay? Visual grading is, remember what I told you before, that Wojtek and we're okay at it. We're not professionals, we're not being trained at it, but we're okay, but we're not very good. Right? We're not very reliable. Dan's maybe a bit better than we are. Okay? But visual grading, you need to be qualified to do visual grading, i.e. properly trained and be doing it all the time. You can't be qualified. Like I was a qualified lifeguard. I got the qualification, but I never ever used it. Never ever got a job doing that. So I would never feel comfortable now being a lifeguard for the day because my training is out of date and never kept anything up. Visual grading for timber, that needs to be your profession. I would say most of the sawmills in Scotland don't do that. They all have the next one, machine grading. Sawmills in England, though, are very different. They tend to be a lot smaller and specialising in hardwood, so they'll tend to be doing visual grading. Right, they'll be doing that, but they're selling it as visually graded, which is not the same as selling timber as if it's mechanically graded. If it's mechanically graded, then it's sprayed on the timber exactly what it is. It's machine controlled and output controlled. There are many methods in Europe around how we can do mechanical machine grading. There's a lovely video here by Dan going through exactly that. I would say, what time is it? That's not too bad. I would say, please watch this video. I'm not going to make you watch it in class. I find watching videos in class is a bit of a cheat. But please do use these scan codes for all the ones you've had so far. Definitely watch this video because there's at least 3 questions in your class test that are in that video. Your first main question is made up of multiple small questions. At least 3 of those are in that video. Right, please watch it. This is the end of, yes?
When is that class test? Or is it not had a...
Have you decided, have you spoke to Vicky yet, and what was her answer?
What is it? So her exam's going to be on Thursday, but she doesn't know. Also going to be on Thursday.
Right. I want to know the week that Vicky's one is. I'll have a chat with Vicky, and the week that she's on it will be the other week, okay? So it'll be on the Monday, that'll be during this time slot. Right? Because if you're able to make it to my Monday class, you'll be able to make it to the class test. It's either week 1 or week 2 of the exam timetable. We'll keep both Mondays free just now. I'll have a chat with Vicky. I don't want you having 3 exams all in the same week. It wouldn't be cool.
But the exam's going to be held in this campus, isn't it?
Sight Hill, because I know the maths one's in Sight Hill.
Oh, hold on.
Yeah.
Right. The maths, right, hold on, let me explain. There's such a thing as essentially timetabled exams, and the mathematics will be essentially timetabled exam. I've argued with people. I've not threatened anyone, but I was quite close to it. Right. If I were to give you a centrally timetabled exam, unfortunately the only way I could do that to have it as an online, sit at home in your class, in your bedrooms, where you all cheat and you all get 100%. And I turned around and said, that's not happening. That's absolutely, we're not giving away degrees here, right? So I've argued point blank, I refuse to do that. I've asked them to change it so that I would formally be allowed to give you a class test. Right? Came back, and as Napier does, that has its own internal policies, they're currently saying they rejected my request for it to be a class test. So currently at the moment, theoretically, they think it's still going to be a centrally timetabled exam. I'm telling you up front that it's not. What you're going to have is a class test. Right? I will jump through hoops if I have to. It will be not in this room though. This room is way too small for a class test because you're all sitting too close to each other. You'll have to sit in a room that'll be flat. It'll probably be B55 probably. Well, I'll figure out the best room for the class test. It will be closed book. You already know that. You will be given some equations, but not all of them. You'll have to remember some of them. I've given you additional material to rehearse weeks 2 and weeks 3, and now that I've remembered, have anyone done them yet? Yeah, you have, right. Well, I'm going to make available weeks 4's additional material. I promise you, right, hand on heart, if you're able to do the additional stuff and all my tutorials that I give you, and there are still some lectures that are coming later on you'll still need as well, if you can do all my additional work that I give you, when you go into that class test, you will be fine. You might not get 100%, but you will be fine, right? Because the class test, being a class test, I'm going to give you something you've seen everything that I give you before, but not presented in the way that I presented it before. You'll have to think on your feet. You'll have to go, oh, sugar, that's what he means. Right, now I've got it. I've given the game away, so I expect to get 100% from all of you, right?
It's going to be in this campus then?
It will be, for me, I will not allow you to do an online, I cannot give you a Sighthill campus one. I can't, I'm not allowed to do that. But yeah, it will be on this campus, it will be a class test, it will not be an exam. It means nothing to you, it just means that I have full control over it. I'll be in the room for the first 15 minutes of the exam. Then I'll be in the room for the full duration, sorry. I'll be in the room for the full duration. If it was a Sighthill one, proper exam, I would be in the room for the first 15 minutes only. After that, I would be asked to leave the room, and you would have 1 or 2 other people who you've never met before, who don't know the subject, and they would be watching you. If I do it my way, I'm in the room for the full duration, or one of my colleagues will be in the room, whoever will be in the room for the full duration, but I will be in minimum the first 15 minutes. And it'll be exam protocol, so all your bags, all your iPads, you won't be allowed iPads by the way guys, but they'll be in your bags at the front. You'll need a calculator. Your mobile phones will be in your bags, your jackets will be down the front as well. All you'll have is pencils. Oh no pencils, pens. Pens, no rubbers, right? Pens, and I'll give you notepads, I'll give you the exam script, which will include things like any equations that I've given you. You will know that weeks in advance of what I'm going to give out, so I'll give you an example of what I'm going to give out, so you can then rehearse those things that you've already looked at, and you probably haven't yet. You can rehearse them again with that handout that I'm going to give out in the exam. Yeah, nice and easy, but trust me, if you do all my additional tutorials, there'll be no real surprises. There will be one surprise, but nothing big, massive. And the surprise it is, we already know, it'll be the same thing, just presented slightly differently, and you'll have to think, well, how am I going to answer that? Oh, I'll just do this. Nice and easy. Right, so when it is via Monday, which one of the 2 weeks? It all depends upon Vicky. Right, okay.
So is it just like the 2-hour time slot then, yeah? Or is it going to be...
No, it'll be probably 3 hours.
Okay.
I want you to answer all the questions. Right, there's another 30 odd slides at the end of this. Highly recommend you look through them. You don't need to, but this next one here would be really cool if you get your phone out. Just get your phone out now and scan this QR code. This one's genuinely worth it. I didn't put it in the lecture because it's not as... Oh no, not this one. No, sorry, I apologise. It is good though. This is, if you watch the video from before, if you watch that video there, so it's only, an 8-minute video or it's only 5 minutes, 29 seconds video, that's all it is. And if you watch that, he talks about all the different types of machine grading and other things, right? Which, I'll be honest, he is an industry expert. When I say industry expert, his team write all the data sets for all of the machines he talks about. Sorry, I'm in your way. His team write all the data sets for all the machines that he talks about there. So when I say he's well known, I mean he's worldwide well known within his field. And he's a Napier person, which is really quite smart. But in that, he talks about this machine here. We call it the Golden Eye. We've got several of them in the UK, and it's for grading the wood, and it's very, very, very fast. So the wood, the log literally goes through the machine and gets x-rayed, two-dimensional x-ray, and it's passed through that x-ray, and it builds up literally models like that, and it then determines how you're going to cut the wood, then determines a cutting pattern and what the grade of each of these boards would be, dependent upon all these defects in that log. And it's incredibly fast. We've got one at Fort William, and it's rapid, absolutely rapid, but it's super expensive. England, I don't think there's any of them in England, I don't think. Right. So it's well worth watching that video, but watch that one first, or that will make no sense. Okay? The rest of the slides are worth looking at if you want to know a little bit more and you want to go into a bit more depth. Right, I'm conscious, I'll make my offer open to not just these three, but anyone who wants to go over the Excel for their second coursework. Happy to go to a computer lab and we'll go over. I know you three put your hands up, but if anybody else wants to join them, I'm absolutely happy for you to join. And then we'll go to the lab at 12 o'clock.
Yeah.
Right. So about 12 o'clock, and then is that right? Yeah, 12 o'clock to the lab. And this session here doesn't happen. That's just going to be now, essentially. Yeah. Maths at Site Hill, yeah? It's a total pain in the arse, right? First of all, you've never probably been there before. Your lecturer has to go there for the first 15 minutes. So they've wasted half a day. Yeah. Total waste of time.
There's 4 separate buildings in Site Hill. So it goes one to the room.
So for those that want to come with me, stay here tonight and we'll walk together, yeah? Fine, long and fast. Well, you find a laptop.
I don't know laptop. I don't use my laptop, but Microsoft Excel's really different on that compared to the past. And it's more specific.
I don't use the vacuum. Yeah, it's like this. I'm one of these weird people, right? I started using my solar commercial, and then, but even then, people had an Apple iPhone, and I changed my Apple iPhone not all that long ago. Then I got myself a new iPhone. Into that. But Mac is a computer, but engineer.
You can't get like Rhino, that you can't get like AutoCAD's completely different on MacBook.
Yeah.
Like all the software. Oh yeah, it's
You
good.
need to manage the lives.
Yeah.
You don't want to manage it.
That's what I'm
Trust me, I know.
But they try to find them as well, so you move that finger the wrong way.
I've got a Mac in the house, it's a desktop, these big Mac. I've got one of those. We only use it for watching movies. It's all much used for it. Honestly. Yeah, so essentially what we want to do, see what these have brought so far. I want to show you an example of what hybrid. These machines are very high power. Unfortunately, run a nuclear system, which makes it running Windows, not Windows. It means it's stupidly slow, but once you do log into it, it does work, but it just takes such a long time. Textbook got a PhD student who's figured out exactly which machines work for him. Some of them just are rubbish. They need pre-imaged, all of them. Why these two will work? Login. Now you're going to find one over there. And I'll start on the one. And it's all I'm doing. You will not get fine. So if you go into the middle, I'll give you a temporary file you can use in the meantime. No, no, just do that because we want it. Then before I can go, do it. Okay. whilst I'm here.
Not working.
Huh?
The set is not working.
Well, that's not how you like it now. I've got to start otherwise it's don't let one do nothing, mate. Just start. That one seems to work. Just leave it there and put it to the side. Let's go. I get it all down to stop now, just leave it after that. Right. So what I'm not going to do, I'm not going to show you a demo of this year's data. I'll show you data from last year's. What I'll do. Um, you've already read the brief, haven't you? Guys, give me a yes or no. You've already read the brief.
Yeah.
Good. So, this is what you're going to end up with, okay? You're going to end up with something like this. What I want to see today is where about these are with that. So there's the original data. There's the original data there. I've copied that over just by way equal minus sign that, and I've just changed the sign for me. So if it's that, of course, what number one exactly the same.
Can you send this file to us?
One more time.
Can you send this Excel?
Maybe not Excel.
Yeah.
No, absolutely not. Absolutely not. The only thing that's different between this Excel and your coursework one, the only thing that, as I say, the only thing that's different about it is how you find F. F max is the thing. For the first coursework, you find F max really, and you find F max really easy, okay? So let me go through how this expression is made. That is just equals minus that cell there, and that for that cell there. Copied all the way down. And your sample size of what's right? And then what we've got is we've got our first guess. Do we have you have you seen the lecture on this module on this coursework?
One fill last week, wasn't it?
No. So then how do you find that?
Yeah.
Well, I do on the board. I do on the board, I do on we haven't talked about that before.
For F max.
So, forget F for a second. I talked about on that. And your gas of F max is that something you ever much? Right. So you've got quite a lot still to do. Right. So what we're going to do with you is all of the stuff that you're going to have to watch, you're going to have to begin catch up from. But the data you've got from last week, you cannot process. Because you need to have an understanding of what's happening here. I can't just show you how to do that spreadsheet. I can show you how to do the various tools that you need, what happens in here. But for you to understand what's actually happening, you need to watch that lecture. I've got it recorded from class.
all the slides on. It's methods 2, tab method 2. But what you're going to want to do just now, though, when I'm going through with these guys, theirs, is if you go to Moodle and you go to Excel tutorial, and you'll want this one here, Excel Part 2 with help. Load that up. Put it on one screen. Like put it on one of your monitors. I'll load it up now, let you see it. And if you can just work through that, and I'll help you with it in between helping these three. So put that on one of your monitors and work through this. It's got all the step by step. Right, everything's written out longhand. And if you can do that by the end of this session before 12 o'clock, if you can manage that, then you'll then have enough tools that you should then be able to create an image, something like this. But then what you'll need to do is before you start, is you then have to go and watch the lecture that follows. But right now, you're shooting in the dark. I can't just show you how to get answers because. Okay, cool. So can you what up and get that? What up and get over age? Yeah, what's that? Right. Put them on screen. Yeah, value Excel. Yeah, value Excel. Value Excel. Yeah. And then just follow instructions and do exactly that. If you guys get your extra things up and doing all of what you've got, now my one will be different from yours, so don't worry about it too much. I might have to do it last year. So expensive. Nice. And you can be fun. That's awesome. Okay, so what's the meaning of line 1 and line 2? One more time. What's the meaning of line 1 and line 2? Well, how about we look at this first of all, and we'll then go into that in a minute, because that's going to let's just go through one step at a time. If we jump too far ahead, I will misunderstood. They're never flying right. Why we do this? We do this because we put it in the laptop. Oh, look at that. You don't even need to do five, but you should. Yeah, that's right. And now the thing with the machine, yeah. You didn't do that, that's obviously wrong. That's obviously wrong. I feel very scared of this thing. No, it's totally wrong. But you know it's wrong. It's wrong. So where's your first guess? You go for your first guess. Six. Yeah. No, it's not. Yes, we know it's not that way. No, it's not your guess. No. Where's your first? Can you show me on this guy? Usually like that when you first test it, show where you test it. This is the same. Yeah. There's an X value. Yeah. Right. So that's your Y. Yeah. There's your X. Yeah, I think so. I'm asking you, so how can the value the force of this form? So, like, let me look at the one first. I think you've got the function of the head, and then you've more on the front head. So just hold on there. I'm just going to use it. And what we'll do is, if we're going wrong, we'll just go all together all at the same time. We'll use my one. Right? Okay. Should we know something? Right. So, that's what you're making up. So I will ask him. You must have to. No, doesn't. I'm looking. Sure, is your roughly the same as that? And have you loaded yours up yet? We do this together. And you may stop doing that now. We do it separately together. Right? This is wrong. No, that's not what I mean. If you do it together, on plagiarism, you do it separately. I don't mind you working together. I still really report copy and pasting. No, we do it working out. Just as for the find the one time. Don't have actually looking for honestly. Yeah. Okay. How about look at nicely? I will record it. Don't look on it. But we watch it and just do it together. Yeah? Okay. I'm not going to do the whole thing. You already know how to done that on screen. Yeah, I love it. Right. Let's do the same thing. Finish the thing. Your guess is the final one. Not really. That's good. Getting you. I'm just giving you what you've got. That's my check. Right. Okay.